This is a molecule of erythrulose, a 4-carbon keto sugar. And you can see we have numbered the carbons. Carbon 1 is on the right-hand side because that enables us to minimize the number that the carbonyl group has. So that's carbon 2, 3, and then finally 4. Carbon 3 is chiral. And behind this, I have built the model for this. You can see carbon 1 here, 2, 3, and 4. And notice that the hydroxyl group here is on a wedge, so it's coming out towards you. And this hydrogen is on a dash, so it's receding away from you in the back here. Now, if I were to ask you if this molecule is R or S, you could probably fairly easily tell me that. However, what if I asked you if this molecule is D or L? Might you have a little bit more trouble figuring that one out? We are going to view the carbon skeleton vertically with carbon 1 at the top. So if you imagine laying on your side, looking at this molecule this way, with this way being up, then you will have carbon number 1 at the top. What you would observe then, looking in this direction, is that the hydroxyl group at 3 would be on your left, and the hydrogen would be on your right. So this then is L-erythrulose. Now sometimes that can be difficult to visualize, but watch this. If I take this model structure, which represents that wedge dash structure in the background, and I turn it around this way, I can rotate the CH2OH group, I can rotate this lower CH2OH group, and now I have the molecule such that I've got carbon 1 at the top, I've got the carbonyl carbon back here, got the chiral carbon number 3 right in front, and then I have the final CH2OH group down here. And notice this is essentially what a Fischer projection is showing. We have the carbon skeleton running vertically with carbon 1 at the top. We have a chiral carbon here in the center, and its horizontal bonds, you can see, are coming out toward you, both the hydrogen and the hydroxyl group over here. And if you'll notice, the hydroxyl group is on the left-hand side. So in this model, which is now oriented as a Fischer projection would be the hydroxyl group on the left, we can for sure say that this is L-erythrulose. And we can represent that then by converting it into the Fischer projection shown here. So I have gone through this and added carbon 1, the CH2OH group, the carbonyl group here, the chiral carbon, and our final CH2OH at the bottom. And we observed that we had the hydrogen on the right and the hydroxyl group on the left. And so this is indeed L-erythrulose.